For decades, the whole green computing conversation has been just utterly dominated by hardware. We obsess over things like how to make servers run maybe a little bit cooler, or how to get them to consume just a fraction less power. But today, we're taking a massive leap forward. We're actually leaving those physical hardware constraints behind for a minute and looking at how organizations can redesign their actual day-to-day workflows to cut their environmental footprint right at the process level. We're going deep into a masterclass on business process reengineering for sustainability. Okay, let's dive into this. Here's a quick roadmap for this explainer. We're going to start with the sustainable workflow shift, decode the BPR methodology, look at mapping from as is to to be, and wrap it all up with the math behind waste audits and impact.
All right, Section 1, the sustainable workflow shift.
To really grasp this shift, we have to look at a clear split between two totally different mentalities. Track 1 is energy-efficient computing. This is the stuff we're all pretty familiar with, right? It's the domain of DVFS, dynamic voltage and frequency scaling. It's tweaking CPU C-states to save a little power, optimizing your hot and cold aisles in the data center. It's that absolute obsession with lowering your PUE, your power usage effectiveness. But here's the thing. Track 1 is hitting a wall. You literally cannot cool a server past the laws of thermodynamics. There's a hard ceiling of diminishing returns there. Now, Track 2, computing towards sustainability, completely bypasses that ceiling. Instead of making a server more efficient at executing a specific task, Track 2 uses business process reengineering as a lever to reduce the total amount of work required before the processor even receives a single command. We're using technology to mathematically reduce the demand placed on the hardware in the very first place. It's a total game changer. This isn't just a bunch of corporate buzzwords either. It is a rigorous, deeply systematic engineering discipline. When you look at how this is taught at the university level, like in this 9-step academic outline, it moves methodically. You start with the foundational theories of reengineering, jump straight into BPMN modeling, and then dive into incredibly strict process waste audits before you ever start applying these tools to real-world scenarios. It just goes to show that pulling off a real Track 2 shift requires a highly structured, almost ruthlessly mathematical approach to understand how to re-architect our workflows for the planet. Moving on to Section 2, decoding the BPR methodology. The absolute bedrock of this whole concept is BPR, business process reengineering. Originally, this was championed back in the day by business theorists Hammer and Champy, and it was traditionally used to radically restructure a company for massive cost savings or, unprecedented speed. But to apply this through a sustainability lens, we take that classic framework and we swap out the core optimization variable. Traditionally, you're evaluating time and capital. But here, engineers actually substitute carbon equivalent emissions for capital in the reengineering equation. So instead of maximizing profit dollars per hour, we're actively minimizing grams of CO2 equivalent per transaction. We're fundamentally redesigning the workflow so the carbon waste never even enters the equation in the first place. Of course, if you're going to mathematically re-engineer a process, you absolutely have to document it first. That means unpacking the basics of BPMN 2.0, the business process model and notation. This is the gold standard visual language for mapping business processes. When you're engineering a sustainable workflow, you have to use highly specific standardized symbols. We're talking parallel gateways, exclusive decision nodes, message flow arrows. If you don't use these symbols to clearly identify, say, a physical transport step or some wildly redundant data processing loop, you literally cannot mathematically isolate the waste variables across a massive enterprise. And this brilliantly illustrates why having a standardized visual language is such a vital, non-negotiable tool for this kind of work. So let's hit Section 3, mapping, as is to be. Let's move to and see how this builds into the core transformation pattern of BPR, the AS's to be method. Step 1 is the AS's phase, and honestly, this requires some incredibly granular data collection. You're out there using your BPMN 2.0 skills to map the physical and digital footprint of every single legacy step. You're conducting time and motion studies, capturing the exact resource draw of the current messy reality. Then, Step 2 is the to be phase. This is where the algorithmic redesign actually happens. We aren't just sending an email telling the office to go paperless. No, we're designing a sustainable future state by structurally rerouting logic to minimize server API calls, stripping out massive database storage redundancies, and consolidating physical asset utilization. Mapping the current reality exposes the exact variables of waste, which gives engineers exactly what they need to draft a highly optimized, streamlined future workflow. So you might be wondering, How do you systematically identify and redesign all these wasteful business processes using real engineering methodology? I mean, it's a profound operational shift, and the answer isn't just drawing a simple flowchart on a whiteboard. The real answer lies in a rigorous mathematical formula. Which brings us to our final part, Section 4, Waste Audits and Impact. Because here's the reality. You can't just claim a new 2B process is sustainable if you can't prove it mathematically. That is exactly where the process waste audit comes into play. To calculate the as-is paperwork footprint, engineers have to tally up the carbon cost of paper production, plus the physical courier transport, which, by the way, is the actual distance traveled multiplied by the vehicle's specific emission factor, plus all that manual processing time. They then strictly contrast that with the 2B digital impact. That means calculating data transmission costs, like gigabytes transferred multiplied by the network's energy intensity, plus the continuous server storage footprint. Only by calculating the precise delta between these two formulas can you objectively, definitively prove the true environmental ROI of your redesign. And the results of that exact mathematical delta, they are absolutely staggering. According to the data, a well-executed business process reengineering overhaul yields a typical waste reduction of 30 to 50%. So the crucial point is, when you apply that delta formula across a massive multinational corporation, that 30 to 50% reduction compounds aggressively. We are literally talking about millions of tons of CO2 entirely eliminated from the atmosphere, which is a whole lot more impactful than just powering your old messy workflow with a slightly greener data center. This level of real-world impact is exactly why mastering these concepts is so critical, and why students studying this are rigorously tested on it through things like applied quizzes and term papers. They have to know how to apply this to paperless workflows, recycling programs, all of it. And actually, this loops us perfectly back around to where we started today. One of the most powerful practical outcomes of this entire methodology is sustainable hardware procurement. By doing Track 2 first, by radically redesigning your workflow to be as efficient as computationally possible, you drastically reduce the sheer volume of Track 1 hardware you even need to buy in the first place. The software and process redesign fundamentally lightens the load on your physical infrastructure. So, look, the Track 1 mindset of fixing the hardware is incredibly important, don't get me wrong, but it has absolute hard physical limits. True sustainability requires us to engineer the work itself. So I'll leave you with this. Are you just making your hardware greener, or are you ready to apply the as-is and 2B methodology to fundamentally redesign the actual work? Think about the hidden logic in your own organization's workflows. Where is the waste hiding in the math, and how would you redesign it? Thanks so much for joining me on this explainer, and I'll catch you next time as we continue to break down the complexities of our world.